photographic imaging, which you used to do in past. Nobody used computers those days. But this digital processing is purely science in numbers. So it's called pixelology. Because all of us, we know that these days, CCD cameras, CMOS chip cameras are used for this kind of imaging, and they are very popular in the amongst astro imagers. And over few years, a lot of good software has come out. There are 8 or 9 different softwares in market, and this is one of the very popular one these days. So I thought that I should try to learn it slowly. It took me 4 or 5 years just to get basic understanding of it. But I hope everyone, even with little knowledge like me, should be encouraged to look in this direction, because this is wherever, if you have any interest in photography now, this is the way to go. So what I'm going to say is not written in rock. It's not fixed. Everybody has their own techniques and variations of digital development, and I'm presenting the way I find it useful for my own purpose. How can I change the slide now? It doesn't change.
Dad, just press down on your keyboard. Dad?
Okay.
Just press down on, just use the arrows, use the down arrow.
All right. So basically, I just don't want to brag about the equipment or anything. The down arrow doesn't work. Now it does work. Okay, good. So this is the second slide. Basically, the idea of this picture is to show what kind of a simple instrument can be used as a refractor or a Schmidt-Cassegrain. But the whole thing is that you have to have a good mount, which is capable of handling all the weight of the equipment, because the cameras are usually very heavy. And not only that, it has to be properly polar lined with the help of a polar line scope here, as you see it. And then software is used, like polar align software, in addition to the external alignment guide, to make alignment so accurate that it tracks the stars within 1 to 2 pixels around each area over a prolonged period of 15 minutes, 20 minutes. So this is a very helpful thing for long exposures, which are usually 5 minutes on average for deep sky objects. My other part of the critical part of the equipment is this digital focuser. This is again, it's got 2,000 steps built in, which is controlled by a motor, and each step only gives you 2.5 micron movement between these two plates. So you can bring the CCD, move forward or backward as much as 2.5 microns at a time. So that, because the focuser is constantly working throughout the procedure as the exposures are going on, because every few minutes or 10, 15 minutes, because the sky conditions change and the direction of the telescope changes, the temperature changes. So it's very important that you have a good digital focuser. This is the camera which I'm using these days. It is a QHY 1620 camera, and it's got a guide camera on the top. And the good thing about this guide camera is that it sits in front of the filter wheel. Filter wheel is in this black box, and the CCD is behind the filter wheel. So focuser, guide camera, prism, followed by filter wheel, and then the CCD chip behind. This is where the light comes from front to back. Okay. Now, there's no such thing called perfect optics. All optics have dust, motes, 30-year-old refractor lens by astrophysics, and over the period of time, these anti-reflective coatings have worn out. And I talked to Alan Ward. He told me, don't touch it. They don't bother you. Screen quality, and he's absolutely right. Then the other thing which is very important is that the chip has to be in this concentric circles as seen from front of the refractor. Because in the beginning, when we were trying this, we have found that our the camera was tilted because it's the eccentric weight load, and you can tip or tilt the camera, and you cannot focus the stars perfectly. So basically, I have to tell right from the beginning, it's a boring thing, but if you have interest in it, you can make it very interesting. The exposure, image acquisition is a janky thing. It's often the case, because sometimes your computers don't work properly. The programs have to be reset. The guide camera does not work. The focuser does not come into the software because it doesn't recognize it. So whenever this happens, always reset your computer right from the beginning. Then the next step is to make sure that you know how to organize data. And the data files are put into individual directories, which are well organized so that you don't lose them or don't lose track of them. Other thing is keep up a backup copies of all your data, because there's a lot of effort which goes into acquisition of data. And if you lose it, so everything which is happening in your computer 2 times. You have to know exactly what you're doing, and you'll perhaps see me doing my errors because it's ingrained. It takes time to learn. But you have to always remember the Murphy's law is always there. And a typical data set at a night has, I'll give you some idea how long it takes. You take 5 minutes exposure per color. So we got R, G, and B filters through which the light is being collected in CCD. So you've got 3 filters, RGB, and then you got 20 frames each. So with 5 minute exposure, you're talking easily about 5 hours of exposure time. And usually that's not even long enough, because during this process going on, you have to download the frames, which takes time. Focusing goes on in between every 10 to 15 minutes, that takes time. Then you have to rotate the dome because the object has moved significantly. I don't have automatic control on my dome, so I have to manually stop the exposure process, go and change the rotation of dome. And sometimes you lose guide star because some cloud passes by in the front of the camera, and there you are. So you get complete stop. So these are the few shortcomings, but as long as you are patient and you have an inclination to keep on working in these boring circumstances. And I can also tell you one thing more. Night fatigue is there all the time. Late hours of night, things don't work properly. Don't lose your patience. You will always do processing during the daytime and your mind is nice and fresh. Don't worry about processing at night. Basically, the test we have created input where we put and we also take darks at night. We have also collected dark for 300 seconds and 120 seconds, which are the common exposure time. And we also, the dark has to be taken at the same temperature as your light exposure. So if you are exposing at minus 30 degrees in the winter, then it has to be at minus 30. The darks have taken minus 30. Just to give idea, this is just organization of how you keep your data organized. And then basically this is what this software looks like when you start. And there are more than 200 different processes and scripts involved, which are available because it's all digital manipulation of numbers. So this software, you are able to collect the image and put it in proper directory by using different processes. And you have to specify which is your output directory so the data goes exactly in the directory which you want. So basically, if you look on the right side, it may not look in great detail, but you can read it, that we are talking about this page refers to linear processing. I'll just try to bring it here to the left if I can.
Dad, it's fine. Don't touch it. You can.
Which I'm going to go back in a second. Basically, okay, all right, okay. So there are two basic components to the digital imaging. One is the linear and other is the non-linear processing. And the linear processing is almost like a mechanized processing, which you do here, where you take the proper step and you got the data collected properly. The non-linear part in a proper
Uh-oh. I can tell my dad's connection is not very good. Let's.
Okay.
Dad, yeah, it keeps disconnect. You know what we can do, Dad?
Uh-huh.
Let me. You talk. I'll put up
Yeah.
the slides on my machine because I
Okay.
think it's just lagging. Is everyone else
All right.
hearing that lag too? Yeah. Okay. Yeah, it's definitely. So I'm gonna step in.
Thank you.
Dave, can you give Manish share or
Yeah.
host?
There you go.
Oh my God.
Manish, you're still on mute.